Okay, let's go.
Good morning, class. Today we'll be looking at motion under gravity. When we talk about motion under gravity, it is still motion, but in this case, there is influence of gravity. So motion under gravity are those motion that has the influence of gravitational force. If I ask you what gravity means, what comes to your mind? Gravity simply means that force that tends to pull objects downward. So forces that are falling vertically, motion that are falling vertically, there is usually the effect of gravity. You remember the last time we treated linear motions, and we talked about motion that are moving in a straight line. Linear motion, we talked about motion that are moving in a straight line. There is absence of gravitational influence. But in this case, the effect of gravity is coming into play. Examples of such motions are: 1. When a boy is falling down a cliff, cliff like a mountain, the boy is falling downwards, there is effect of gravity. There is effect of gravity. When a bullet is released from a gun and the bullet is falling back to the surface of the earth, there is also effect of gravity. The list goes on and on. Now, the gravitational force has been taken to be approximately 9.8 meters per second. But when it comes down to the surface of the earth, it varies. It varies. That is why in a question you will be asked to assume that acceleration due to gravity is constant, and the value will be 9.8. In some cases, you will be given 10 meters per second squared. So, motion under gravity and linear motion, they are related. The only difference there is just the effect of gravity. So, from the equation of motion that have been established earlier on in our previous classes, you will replace, remember in the equation of motion, we have A to be acceleration. But in this case, under gravity, you replace this to be G, which is acceleration due to gravity. Then we also have X, which is distance. In linear motion, it is a linear distance, horizontal distance. Now, since you're considering motion under gravity, you will replace it with your vertical distance, which is usually written as H, vertical distance. So these are the things you will replace in linear motion to get the equivalent of equation under gravity. So these are the things you will replace. Change X to H, change A to G. Then again, another thing you should consider is the object falling vertically downward or is falling vertically upward. When it is falling upward, it is assumed that it's going against gravity. And when it is going against gravity, you assume G, which is acceleration due to gravity, to be negative. But when it's falling downwards, then it's positive. This is what I mean. You have, let's assume you have, this is what I mean. Assuming the object lifts, this is the ground level, the object lifts through this direction, it means that it is going against acceleration due to gravity. Therefore, g will be negative. But when it is falling from a height to the Earth's surface, g is positive. Take note of that. Remember I said the equation of motion under gravity is derived from the equation of linear motion. Remember that this is the first equation of linear motion. And I told you earlier on that when you see A, you replace it with what? Ordinarily A is acceleration, but in this case, since it's under gravity, you replace it with G. So this equation becomes V is equal to U plus or minus. The presence of this plus or minus is telling you that G can either be plus or minus, depending on the nature of the motion. So if it is falling under gravity, you use plus. If it's against gravity, you use minus. That is why you see plus or minus here. Then this A has been replaced with G, so you get equation 1. Similarly, you do the same thing to equation 2 of linear motion. You change the x to h. You change the A to G. The same thing applies to the third equation of linear motion. Change the x to h, which is vertical height. Change the A to G. It's as simple as that. But always pay attention that when it is propelled upward, it has no final velocity. It's leaving with an initial velocity. So in this case, final velocity V is 0. But when it is released and is falling downwards, you have U to be 0. Let's take an example. Let's take a simple example. Remember, we go from simple to complex. This question says, a ball is released from height above the ground. Find its velocity after 5 seconds. Take g to be 10 meters per second. So in this case, you are giving g to be 10 meters per second, so you work strictly with it. If you are giving it to be 9.8 meters per second, you work with it. But if you are not given, you can assume either of them, either 9.8 or 10 meters per second. So we're working with it. So in attempting this question, you need to read it over and over again until you understand it, because if you don't understand the question, you can't approach it correctly, the right way. So a ball is released from height. First thing that comes to your mind, a ball is released from height above the ground. So someone that is releasing the ball is above the ground, is at height. That means the ball is falling. So when it is falling, is it against gravity or is acting along gravity? If it is falling, you said it's acting along gravity. Therefore, G will be positive. So we have G to be equal to plus G, which is equal to 10 meters per second, which is given. That value is given. Find its velocity after 5 seconds. Now, since it is released from height, that means that U, which is initial velocity, is equal to 0. Find its velocity after 5 seconds. 5 seconds is talking about t, which is time. 5 seconds. Remember, the SI unit of time is in seconds. If this time were to be given in minutes, you have to convert to seconds. If it's given in hour, take it to seconds. If it's given in days, just convert it to seconds. Now, another thing that comes to your mind is, which of the equation of motion would be suitable for what to solve this particular problem? You look at those equations of motion. What are you looking for? You are looking for V. That is the unknown. So which of the equation has V and also have the parameters at your disposal? If we look at equation 1, we already have U to be 0. We have G that it is given to be 10 meters per second. I also have T. The only unknown here is V. Therefore, equation 1 can go. So quickly, we now apply equation 1. V is equal to U plus GT. If we substitute this, V is equal to 0 plus 10 times 5. So that V will be equal to 50 meters per second. It's as simple as that. Let me run down through it again. You read the question to be sure you understood what the question wants from you. Then next step is, what are you looking for? What's unknown? After that, you go to the equation of motion. Which of the equation best suits your needs? Then finally you apply it. Alright, let's look at another example.
Yeah. Let's go.
Alright, let's look at the second example. This one says, an object is propelled upwards with an initial speed of 100 km per hour from a point P. Question A. Find the maximum height reached above the point P. Question B. The times when the object is 5 meters above the point P. Like I told you earlier on, you need to read the question over and over until you are sure you understood what you are asked to do. Don't rush the question. Make sure you understand what you need to do there. So, if you look at the information provided, an object is propelled upward, that is projected upward. This time it's not like example 1, when the object was falling from a height. In this case, it is propelled upward. So what does it tell you? It is going against gravity. It's propelled upward with an initial speed of this. So its initial speed, which you can actually say is initial velocity, is given to be 100 km per hour. Remember, this is physics. You need to work with the right SI units. Speed of velocity is measured in meter per second, I beg your pardon. But in this case, you are given it in kilometer per hour. So you need to do a little conversion. So how do you convert kilometer per hour to meter per second? I believe we've done that earlier on, but let me remind you that 1,000 meters makes 1 kilometer. And 3,600 seconds make 1 hour. So for you to convert this to meter per second, you do a simple math. U is equal to 100 times, take it to the 1000, all over, take this into seconds, 60 times 60. 60 times 60. So if you do this computation correctly, let me take away this. You're having 1000 over 36, 1000 all over 36, 1000 over 36. That is working with one place of decimal. Now you've gotten the initial speed or velocity as the case may be. The next thing is, which other thing do you have at your disposal? G is not given to you, so you can assume any value. For the sake of this example, I'm assuming G, but G is, I'm assuming it to be 9.8 meter per second. So far, this is the only thing parameter we'll have now. The question said we should find the maximum height. So like I said, which of the equation of motion has distance or height, as the case may be? You observe them carefully. If we look at equation 2, it has height and initial velocity. If we look at equation 3, it also has height, acceleration due to gravity, and time. But, so it means that any of these can actually go, because already we have our initial velocity calculated it to be 27.8. And when an object is released from height, the final velocity we said should be what? 0. So if we apply v square equal to u square, so in this case it's going to be minus because it's going against gravity, minus 2gh. What is the unknown here? The unknown here is in height, which you are asked to calculate the height. So you can make it a solid formula. We know that this is 0. So this is now 0 equal to u squared minus 2gh, which means that u squared is equal to 2gh. Therefore, h, if we make h separate formula from this, h will be u squared all over 2g. So you can now substitute the values. You have your u to be this, and you have your g to be 9.8, which means that this is going to be 27.8 squared all over 2 times 9.8. Okay, so if you compute this correctly, that will give us 772.84 all over 196. All over 196. sorry, not 196, 19.6. Beg your pardon, 19.6. If you do this division, you will get 39.4 meters. That means that the maximum height reached above point P is 39.4 meters. That is the maximum height according to the information given. So, the B part of the equation said we should calculate the times. Take note of that. Times. It said times. Pay attention to that. Times. Not just time. Calculate the times when the object is 5 meters above the point P. So what you do is look for the equation. Look for the equation that has distance, because as a particular distance has been specified, which is 5 meters. A particular distance has been specified, which is 5 meters. So, of all the equations that has distance, the only equation that has distance and time, from equation 1 to 3, the only equation that has distance and time as well is equation 3, which says that h is equal to ut plus, remember this it's moving upward, so we are going to use minus half gt squared. Minus half gt squared. Here, h is equal to 5 meters. It is given. This is the given distance. H is 5 meters. Now, t is the unknown here. T is equal to unknown. Maybe in the bracket, alright, unknown. U, which is the initial velocity, it is also given as this. U is equal to 27.8 meters per second. So you should of course, we know that G is, we've assumed G to be 9.8 meters per second. You substitute these values into the equation. So we now have it to be 5 is equal to 27.8 times t. Let me do it gradually. Times t minus 9.8 times t squared all over 2. So this will give us 5, if you do it correctly, equal to 27 times t will give us 27.8 t. 9.8 divided by 2 will give us this will give us 4.9 t squared. So remember the t, which is the time, and the equation say times, are the unknowns. So you need to rearrange this equation. If we rearrange this equation, this will give us, let's bring the t squared to start the equation, this will give us minus 4.9 t squared, this is t here, plus 27.8 t. If this 5 is crossing the sign of equality, it changes to minus 5. Minus 5 equal to 0. Like I always tell you, it's not usually comfortable to leave the minus sign in the beginning of an equation. So you can multiply through by minus 1 to cancel out the minus. If we do that, we will now have 4.9 t squared minus 27.8 t plus 5 equal to 0. If you observe this equation carefully, you will know that it looks like the quadratic equation you have in mathematics. Something that looks like this: ax squared plus bx plus c equals 0. So you can either solve this by any of the methods you've been taught in tackling quadratic equation, maybe factorization, completing the square, or the formula method, which some of you call romantic formula. Looking at this alone, because the presence of the decimal, you know that factorization cannot work. So, if we use the formula method to make it quicker, we use the formula method. Here, A is equal to 4.9, B is equal to minus 27.8, and of course, C, which is the constant, is 5. You remember the quadratic formula says that x, but in this case it's going to be t because t is unknown. This equation is, the variable here is t. So we're going to use t is equal to plus or minus b squared minus 4ac all over 2a all square root. You've been able to identify the coefficient of x squared. So in this case, it's going to be the coefficient of t squared, which is a, coefficient of t, which is 27.8, and of course, a constant, which is 5. So you substitute into the quadratic formula. If we do that, so this is minus b plus or minus, take it back. So we now have b, we said b is minus 27, and in the formula you have minus b. So it's going to be minus 27.8. Let's enclose it in a bracket so you don't get confused. Plus or minus 27.8 all squared minus 4 times a is 4.9, and of course c is 5, all over 2 times 4.9. Remember their own square root. I will advise you to do this computation gradually, don't be in a hurry. So first of all, you get minus times minus automatically changes this to plus. So we now have 27.8 plus or minus. Now what is 27.8, minus 27.8 squared? If you do all this computation, minus 27.8 squared, minus 27.8 squared, we give you this, and for everything here amounts to 98, and of course 2 times 4 will give you this. Please, when you get to this stage, A lot of students make mistake by solving this as a fraction. No, you don't do that. Solve this independently, which is the square root of 647.84 giving us 25.98. There's a range of value here, plus or minus. So this added to this, all over this, or this subtracted from this, all over this, which is what I did here. Look at it. So at the end of the day, t is now, that is this over this will give you 5.5 seconds or 0.2 seconds. So consequently, what it means is that the object moving at 5 meters, when it was initially released, it moved. For it to get to 5 meters, it's now 0.2 seconds. Getting downward to another 5 meters, you now have 5.5 seconds. Which is why, remember I told you that the question said you should look for the times. It didn't say time. Some of you will be quick to solving just one t. Look for times. The examiner already knows that it is not just a particular time. He knew that already before asking you. So the times, we now have t1 and what? t2, which is now t equal to 0.2 seconds and 5.5. Our approximation here is 1 decimal place seconds. Now, for your assignment, remember to leave your questions at the comment section. I will attend to them. Your assignment I will refer you to the note to this particular tutorial. Go to the note. There's an assignment there. You solve it. Of course, you're expected to submit it. So go to the PDF file, uploaded under its video, turn to the assignment. When you're confused, note down your problems and I will attend to them. Thank you. So Hakim, morning sir.